What if your car could see around corners, detect black ice before your tires ever touch it, or even clear a path for an ambulance miles before it arrives? That's not science fiction. It's the reality of collaborative sensing where cars, cities, and infrastructure actually share their sensor data to create a single, collective intelligence for safer, smarter roads. Right now, self-driving cars and smart cities are evolving in parallel but separately. Cars depend on their own sensors, like LiDAR, radar, and cameras. Cities rely on fixed infrastructure, like traffic lights, cameras, and monitoring stations. But imagine combining them into one massive network of eyes and ears. Instead of each car seeing only what its sensors allow, the entire ecosystem contributes to a shared, 360-degree understanding of the world. This is the power of collaborative sensing, and in today's video, we'll explore what it is, how it works, real-world applications, the benefits and challenges, and where it could take us in the future. In simple terms, it's when vehicles, infrastructure, and devices share their sensor data with each other, instead of working in isolation. Think of it like this. One car's LiDAR scan might only cover 200 meters ahead, but if that data is shared with nearby cars, traffic cameras, and roadside sensors, suddenly, every participant sees much further beyond line of sight, around blind corners, and even through heavy fog. This is powered by several key technologies. V2X communication vehicle to everything allows vehicles to talk to each other and to the city's infrastructure. 5G and future 6G networks deliver ultra-low latency, so data is shared in real time. Cloud and edge computing process the massive volumes of sensor data without slowing things down, and AI-driven sensor fusion combines all that raw data into something useful and accurate picture of the road environment. At its core, collaborative sensing is built on a simple truth. Many eyes and ears are better than one. Let's break down how collaborative sensing is transforming autonomous vehicles. Vehicle-to-vehicle V. Cars can communicate directly with each other. Imagine you're driving on a highway, and the car ahead detects a patch of black ice. Instead of you finding out the hard way, that data is instantly broadcast to nearby cars, so they adjust speed before reaching danger. Or picture a sudden traffic jam. One car slams on the brakes, others down the line know immediately, avoiding pileups. Vehicle-to-vehicle structure, V2I. Now add the city's infrastructure into the mix. Smart traffic lights, construction zones, and road sensors send real-time updates directly to vehicles. For example, instead of waiting for a green light, cars could anticipate it seconds ahead, smoothing out traffic flow and saving fuel. Swarm intelligence. It gets even more fascinating when fleets of autonomous taxis or delivery vehicles work together. They share routes, road conditions, and traffic density in real time, essentially operating as a swarm that distributes itself intelligently across a city. Think of bees coordinating in a hive but on 4 wheels. Of course, cars aren't the only ones with sensors. Cities are increasingly packed with IoT devices, cameras, pollution monitors, weather stations, and even roadside LiDAR. When these systems connect with vehicles, we unlock powerful applications. Traffic flow optimization. Data from thousands of cars and roadside units helps adjust traffic light timings dynamically, reducing congestion. Predictive maintenance. Shared signals detect potholes or cracks early, so repairs happen before accidents. Emergency response. If an ambulance is on its way, the city system and cars coordinate to clear the fastest route in seconds. This feedback loop is critical. Cars feed data back into the city, and cities, in return, make driving safer and smoother for everyone. One of the stars of collaborative sensing is LiDAR. It creates highly accurate 3D maps of surroundings, but it's limited by weather, cost, and line of sight. Here's where AI and data sharing come in. Sensor fusion. AI combines LiDAR with camera and radar data, plus external data from other cars and city infrastructure. Federated learning. Cars themselves become mini AI training nodes, learning from their experiences and sharing knowledge without giving away private raw data. Real-time mapping. Imagine an ever-updating, high-definition 3D map of the entire city, constantly refreshed by millions of sensors. This kind of collective mapping is essential for scaling autonomous vehicles in complex urban environments. So what do we gain from all this? The benefits of collaborative sensing are massive. Improved safety, fewer blind spots, faster hazard detection, and better emergency coordination. Greater efficiency, smoother traffic flow, reduced idling at lights, and optimized delivery routes. Sustainability, less congestion means lower emissions. Smarter traffic systems reduce wasted fuel and energy. Resilience. In disasters, shared sensors can guide evacuations, locate hazards, and maintain critical mobility. But it's not all smooth roads ahead. Collaborative sensing faces serious challenges. Bandwidth and latency. The sheer data load is staggering. Each LiDAR scan can generate gigabytes per second. Without ultra-fast 5G, 6G, or edge computing, delays could be dangerous. Privacy and security. If cars and cities are constantly streaming sensor data, who owns that data? Could it be hacked or misused for surveillance? Standardization. Automakers, governments, and tech companies all use different protocols. Without global standards, collaboration is fragmented. Economics. Why should companies share valuable data with competitors? Incentives and governance models are still unclear. These challenges aren't small, but they're not insurmountable either. So where is this all heading? Experts envision AI-powered data. Trust neutral platforms that anonymize and fairly distribute collaborative sensing data among cities, automakers, and service providers. Beyond transportation, the same shared sensor ecosystem could support drone coordination for deliveries or disaster relief, crowd management during major events, environmental monitoring to track pollution and climate change in real time. In the long term, collaborative sensing paves the way for collaborative autonomy. Not just cars driving themselves, but cities, vehicles, and infrastructure evolving into a single, intelligent network. A future where no vehicle drives blind, no city reacts too late, and mobility becomes safer, cleaner, and more connected than ever before. Collaborative sensing is more than just a buzzword. It's the foundation of tomorrow's transportation. From self-driving cars, sharing LiDAR data, to smart cities coordinating traffic and emergencies, the road ahead is built on connection. But the big question is, are we ready to balance the privacy, costs, and trust issues that come with it? Because if we get it right, the future of mobility won't just be autonomous. It will be collaborative.